if you should need that.
I don't see an example 13. There's 10, 11.
Okay, let me look and see why that's not showing up.
Example 10 starts at slide 6.
Okay, yeah, I realize now I've gone too far. So 10 and 11, okay, but you're right, 13 is not in there. Okay, I will print off example 13 for everybody so that you can actually write down notes on it. So let me bring up my PowerPoint. I must have forgotten to add it to the notes. It's example 13 in the book.
To the issue.
Yes. Oh, that stinks. We'll do it another way. Okay, so example 10 says, in recent years, the percentage of the U.S. population 18 or older who smoke decreased, and that word decreased is an important word in that problem. It decreased at a roughly constant rate. Now those words are important because what those words tell you is that this is a linear function. A linear equation, function equation is basically the same thing. Function has some restrictions on it though. And the fact that it decreased tells us is that m is a negative number. The slope is a negative number because it's going downhill. Okay? And it says it went from 20.9% in 2005 to 18.1% in 2012. So what they want us to find the linear equation that models this percentage of the population. And we already know that a linear equation looks like y equals mx plus b. So that's what we know. So now we need to make some sense out of this information. We know that in 2005, the percentage of the population that smoked was 20.9%. That actually is going to give us an ordered pair. But I really don't want to use such a large number as 2005 for my X value, because in this linear equation, X is going to be the time, the point in time when this thing happened, and then Y is going to be the percentage. Okay? And 2005 really is a large number to deal with, and while the math's not that hard, what I'm going to do is I'm going to define the X value here to be the number of years after 2000. This is something called scaling your data. We're going to be using that idea quite a bit in this class. It's called scaling your data. You're trying to use the information that you're given, but you're trying to reduce the actual value of the number to something smaller and more manageable by setting what we call a base year. So we're going to use 2000 as the base year so that we can just talk about X as 5 years after 2000. And it's not really that crucial that we do it in this problem because it's linear, but later on we're going to have to do, we're going to fit models to quadratic equations. We're going to find models that are cubic or maybe rational. And those, when you start putting in large numbers for X, think about what happens when you square a number. 2005 squared would be huge. And then that leaves a lot of possibility for error when you actually try to use your calculations and you round something off. So we're going to scale the data. That's what that's called, is scale the data. Or scale our information. That means then that my first point is 5 for 5 years after 2000, and then 20.9 for the percentage. Also tells me that my other point, 2012, is 12 years after 2000, and the percentage is 18.1%. So 18.1. And now that I have that information, I can easily find the slope. So the slope, remember, it's something we call a difference quotient. The top is a difference, a subtraction operation. The bottom is a subtraction operation. And it is a quotient because we're going to divide those. Doesn't matter where we start, where we end. But we need to get the points lined up over either side. So we're going to go from 2005, which is X equals 5, when it was 20.9, to 2012, when the percentage was 18.1. And we'll calculate the slope. So I'm going to grab a calculator. And 20.9 minus 18.1 is 2.8. And 5 minus 12, I think I can do that without a calculator, is -7. And this turns out to be -0.4. Okay? Now, normally I want this as a fraction. But, you know, -0.4 is 4/10 or 2/5. since we've used this as a decimal to start with, let's just go ahead and use it as a decimal. So it's going to be negative 0.4. That's just another way to represent a fraction. So I now have my slope. My question then becomes, well, okay, what's the y-intercept? Now there's two different ways that you can go about finding the y-intercept. You can use the formula we have already in front of us, y equals mx plus b. Because I don't like memorizing extra formulas or using extra formulas. And I'm going to pick either of the points, and just because I'm going to pick this to be one of the points that I'm going to use. And I'm going to use the x value of that point, which is 5, and the y value of that point, which is 20.9. And I'm also going to use this slope that I found over here. And what you'll notice here is that now that I've done that, I only have one unknown in that equation, and that's b, the y-intercept. So, little algebra. Negative 0.4 times 5 is negative 2. Add 2 to both sides, which takes it away here. And 2 added to 20.9 is just 22.9, which is equal to the only thing left on the other side is b. Now I know the value of b. So I need the linear equation. Well, now I can make the linear equation. The linear equation is, remember this is your slope, and the value of b is going to be 22.9. So my linear equation is y equals negative 0.4x plus 22.9. And in order to turn that equation into a model, because again, we're not just all about the algebra here, we're about actually being able to apply this. So to make that into a model, y represents the percentage of the U.S. population 18 or older that smoke. I'm going to say percent of U.S. adult smokers. So kind of trim that down a little bit. In X year after 2000. So a linear model is a linear equation. Here's your equation. But you have to have some words that explain what does y actually represent, what is y talking about, and what does x represent. And this tells you that y is the percentage, like it says there, and that x tells you the number of years after 2000. So you want to be sure that you include those words to have a model. Because when y'all get out of here and you graduate and you go to work, your boss is not going to say, okay, for today, here is your day's work there, here's 50 algebra equations to solve. Now you know that's true, right? Those of you that have a job right now, your boss never says, okay, do all these math problems for me. Your boss says, this is the problem that I'm having and I need you to find an answer and tell me what the answer is. And if you answer him in a number, he's going to look at you and say, eh. Okay? She's going to say, what does that number mean? Can you explain to me in English? So you need to be able to communicate math as well as to do arithmetic. So there's the answer to the first question. Now there's actually a second question. I'm going to leave that one handy for a minute, but I want to look at the second question. Second question says, one objective of Healthy People 2020, which is a campaign of the U.S. Department of Health and Human Services, is to reduce the percentage of U.S. adults that smoke to 12% or less by the year 2020. So here comes that problem. Here comes your assignment. If this decline in smoking continues at the same rate, will they meet that objective? Are they going to make the goal? Well, first thing we're going to do to answer that question is we're going to use that model that we made . Remembering that we have all these words that go with it too, but in order to get a number, we're going to need to plug into the equation. So that's the only thing that I recorded was the equation. And then I need to pick out some information. It says they want it to be 12% or less by the year 2020. So what would the X value be for 2020? X would be 20, because it's 20 years after 2000. So what I'm going to do is I'm going to exchange the X in this problem for the number 20. Y equals negative 0.4 times 20 plus 22.9. And it will be 14.9%. So now we can answer the question that they have. So, if the decline continues at the same rate, the percentage of U.S. adults who smoke will be 14.9%. They will not reach their goal. That's the answer to the question. That number is not the answer to the question. The answer to the question is contained in the question. You have to tell me what is the question asking me and how does this answer the question. So since the question is, if this decline continues at the same rate, will they meet the objective? If it continues at the same rate, the percentage of U.S. adults who smoke will be 14.9%. They will not reach their goal. Now you could phrase that other ways, but you're going to have to answer in a sentence that communicates the answer to the problem. If a problem is given to you and it's nothing but numbers, then a number is fine for the answer. But if a problem is given to you in words, then the answer to that problem is going to be words. And life is a word problem. Okay? It always has been, always will be. Real life is a word problem. Now, the part that I want to look at with you, and this is in the PowerPoint, but I can't really effectively show you how I did this without actually having the calculator. So with that sitting there, I'm going to show you how we can use this whole idea on a calculator and be able to come up with that equation without doing any of the work we just did. We're going to let the electronics take care of the arithmetic for us. So this is how we're going to do that. We're going to start out with the, I know this is a math class, but we're going to go to the Stat menu on your calculator. We're going to be using this feature, this button, quite a bit in this whole course, now and at the end. We're going to hit Edit, which just means hit Enter. And I've got some stuff in my list. If you have stuff in your list too, then just hit your Delete button. Till all that stuff goes away. And to be honest with you, yes, there is a faster way to do that, but it usually results at some point in you doing your homework at home whenever you have to do it, which for some of you is like 1 or 2 in the morning. You're going to sit there, if I show you the other one, you're going to actually manage to delete all your lists and think you broke your calculator, and I can't help you at 2 in the morning. So I'm just going to avoid even telling you how to do it the other way and just tell you, hit delete till it all goes away, because you can't mess anything up that way. Okay? Now, what I want you to do is enter in the 2 points that we have from the problem. So remembering the problem, the original problem, and this is going to be the only thing you're really going to have to do as far as any math at all. We're going to enter in the point 5. Oops, wrong list, sorry. 5. And then go over to the other list and put in its y value, which is 20.9. We're going to go back to the first list, which is my x values, and I'm going to put in 12. And then go over and put in its Parker, which is 18.1. Okay, so we're just going to enter the 2 points into the list in the calculator at the Stat button. This is like a spreadsheet. Now, what we're going to do next is we're going to press Stat again. We're going to hit the right arrow button and go over to a menu that says Calc. Calc is the calculate screen. And what I want this calculator to do for me with the information I just gave it is I want it to tell me what is the linear model that fits those 2 points. Give me the linear equation that goes through those 2 points. So I'm just going to pick the linear regression model and hit Enter. And it's going to default to using list 1 and list 2, so you're not going to have to enter any list names or numbers. And it says the equation is y equals ax plus b, where a is negative 0.4, fixed price, and b is 22.9. So from there, you can actually write down your equation. And this is all explained in the next slide on the PowerPoint, but it's better if I show you. I think you can see now that it's better if I show you. Now, what I'm telling you on here is that if you want to store the equation for some reason, you can actually store it. Let me just clear that off again and go Stat, Calc. Go down and choose number 4. And then if you want to actually store the equation, you have to tell it, this is where my x values are. 2nd and 1 is list 1. And put a comma, and then 2nd and 2 is list 2. And then put another comma. And if I hit my bars key and go to y bars and choose function and y1, all of which is explained over here on this slide, and hit enter, this doesn't look a bit different. But what does look different is that if I hit my y equals menu, now it put the equation in y1 for me.
that when I go there and hit number 4?
Go down to store regression equation, just go arrow down, and hit vars, hit your vars button, right next to clears. And then enter 3 times. Okay, now hit it one more time to calculate the equation. Right. And if you hit your y equals button, you'll see the equation and your y equals list just like I already did. Okay? Now, in order to relieve you of having to do any arithmetic, and I'm just showing you this now, you don't have to always do it this way, but later on you're going to find this to be really handy. I can actually get answers. I'm just going to quit from that screen and go back and do bars and over to y bars and hit enter 3 times, or 2 times, I'm sorry, not 3. And then in parentheses after that, what year was it they were trying to predict for? 2012, which was 12 years after 2000. And there's the answer. Look. 2020, sorry. And I'll show you the vars thing again because the more you do it, the more likely you'll remember. So you hit vars, right arrow to y vars, hit enter for function and enter for y1. And then it's what we're telling it when we put these parentheses in here is go get that equation that's over there in y1 and I want you to plug in 20 and tell me what the answer is. So it does. Okay? And if we want to know when they are going to reach their goal, we can just keep going and say, well, what happens by 2021? Nah, it's only 14.5. So apparently it's going to take a while. Let's see what happens at about 2025. Close.
I don't know, I'm trying to figure that out.
They passed their goal. So somewhere after the beginning of 2027, they'll reach their goal of 12%. Because at the beginning of 2027, it's at 12.1%. So by the time they get to 2028, then they'll have reached their goal. Okay? Now that's not necessary to do for the problem that I actually gave you the example. It's just kind of a way to show you that there's a lot of good work you can do on your calculator to save you from doing so much pencil and paper arithmetic. And we want to use the technology as much as we can. Now, example 11 says to graph a line. If you're given the equation, let's graph a line. Well, there's several ways to graph a line. If you're given this equation, this kind of recaps everything we've done in this whole entire section. One way you could do this is you could take this equation and realize that this gives me the y-intercept of the equation, which is 0, 6. So I plot the point 0, 6. And then this tells me how to come up with another point. This is the slope of the line. So this says, and I'm going to arbitrarily put the negative sign in the numerator. This says from 0, 6, go down 3. And because that one's positive, go right 2. So I'm going to go down 1, 2, 3, and then right 1, 2, which gives me this point. And not only that, but I can do that same thing again. Down 1, 2, 3, right, 1, 2. That gives me another point. And then once I've got that point, it's easy to lay a ruler down there and see that they all line up in a straight line. So you use your ruler and you draw the straight line. And yes, I do expect you to use a ruler and draw a straight line on your test and on your homework. Okay? Now, just as a word of advice, since I'm using this, I need a bigger ruler. If you've got a credit card or your driver's license on the size graphs you're probably going to draw, either one of those makes a perfectly good ruler. So, you know, rather than it just taking up space in your wallet, haul it out of your wallet, use it for a ruler, but just don't forget to put it back. Okay? So there's one way to graph that line. This is called the slope-intercept method. Which is what makes that such a valuable way to have your equation arranged. Another way to do it is go to your y equals menu on your calculator and enter in negative, and then the fraction is 3/2. You always put your fractions in parentheses, times x plus 6. And then from there, hit your zoom button, which takes you to the zoom menu. There's a lot of different choices here. We'll use different ones at different times. But for right now, we're going to go down and choose zoom 6. And zoom 6 is just your standard -10 to 10 on the x-axis and -10 to 10 on the y-axis. And then there's your graph of your line. So you can, in order to actually plot some points and be able to draw that line, then what you can do here is hit your second calc menu and choose value and use this to get some points. So what if x is 1? Well, then its y value is 4.5. And once you get that up there, you can actually, I think, just type another number like, what if x is 5? This is okay, then the other point is 5, -1.5. Okay, what if x is 7? Okay, 7 and -4.5. So you can plot your points by using your calculator to help you find those points without having to do any math, without having to do any arithmetic. So my goal, besides you learning how to do all these things and apply them, is to learn how to use the technology to work for you. It's supposed to be your slave, not the other way around. Okay? It's supposed to help you. Now, example 13. I probably need to leave that up there. I don't know what it is with this thing that keeps locking up. If that's where you can see, where I can see the table and you can too. We've got a table of years and the cost of public college tuition and fees. And the problem says the table on the left lists the actual annual cost in dollars of tuition and fees at public four-year colleges for selected years. This is information that was collected by the College Board. And they want us to plot the cost of public colleges by letting T equals 0 correspond to 2000, and that's the year 2000. So there's that idea of scaling the data. Okay? And it says, are the data exactly linear? Now, I do not expect you to haul out pencil and paper necessarily to do this. If you did haul out pencil and paper and do this, your graph would look something like this. And if I want you to actually do a graph like this, I'm going to actually give you a graph grid on the problem and ask you to plot the points. But I want you to actually use your technology to help you do this. So we're going to come over here and we're going to actually use what I showed you just a second ago. That was why I showed you with just 2 points. We're going to get the calculator. And I'm going to clear off the home screen so we don't have any extra stuff. And I'm going to clear off that equation because we're going to start over. We're going to go back and press the stat button like we did a minute ago. But the difference is this time we're also going to enter more than 2 points. Now, since I have a lot more years here than I do just 2, I don't have to delete those. You can if you want to. But what you want to do is you want to type in how many years past 2000 is each one of those years. So the list 1, x equals 0 corresponds to 2000. X equals 2 is 2002. X equals 4 is 2004. 2006, 2008, 2010, 2012, 2013. And then right arrow to get your y values. 3508, 4098, 5126, 5804, 6599, 7629, 8646, and 8893. And I realized just now that I should have been typing over the top of those numbers, so let me delete out those first 2. So be sure that you get that information from this table typed into list 1 and list 2 of your calculator. And be sure once you've done that, that both of those lists have exactly the same number of entries in them. That's critical. Make sure that you typed it in right. Now, if you didn't have technology to help you, you'd have to think about, okay, I'm supposed to graph this, so what numbers do I need to put on my x-axis? What numbers do I need to put on my y-axis? How far do I need to go? Do I need to go into negative numbers, or should it just be positive? With this calculator, you don't even have to do that. Okay? What I want you to do is I want you to hit second and y equals, not y equals because there's nothing there. It's second y equals. Press enter where it says plot 1. Press enter again to turn it on. And if you haven't used your calculator for anything before, probably the rest of your screen looks like mine. Now, if you've got a TI-84, and I forgot to bring my TI-84 today, it'll say X list, and it should say L1, and Y list, and it should say L2. And then it should give you the chance to put a mark, so it may look pretty much like this one, okay, if you've got a TI-84. The only thing you need to be concerned about, as long as it says L1 and L2, you don't need to mess with the mark, but if for some reason one of these other graphs is highlighted, not the first one, you want to make sure that you put your cursor on that first one and hit enter to make sure it stays on. Okay? So make sure your screen looks like mine.
Go down to that thing and hit it.
Yeah, you just go straight down the page. So it needs to be on, it needs to be the scatter plot, and if it's not, then press enter while you're sitting on the scatter plot. And then make sure that says L1 and that says L2. It should, because unless you've changed it, that's what it defaults to. And then leave the mark what it shows, because it makes nice big points so you can see it easily. Okay? And then your next step, this is how you get your graph paper. Okay? You're going to hit the zoom button, which is why I showed it to you a couple of minutes ago on another problem. And on this zoom button, I want you to scroll down to option number 9, which says zoom static. Option 9 on the zoom key goes with stat plot. They work together. So choose zoom 9, press enter, and don't touch it. Just watch what happens. Does that look anything like the graph that you see there in the book?
Yep.
Looks exactly like it, except there's no line through it, right? Now I want you to examine this very, very closely. Are those points perfectly straight? No, they wiggle just a little bit, don't they? But would you say they form a more or less linear pattern? Could you draw a line that, if it doesn't actually connect them all up, would the line at least run through the middle where all those points are really, really close to that line? Yeah, that answer is yes. So then, if I want that line this says use those 2 points to find the equation of the line. We're not going to do any arithmetic. We already know the calculator can take those points in list 1 and list 2, and it can come up with the slope and the y-intercept. So why should we work and do arithmetic by hand to do that? So we're going to let the calculator make that line. We're going to hit the stat button. We're going to go over to the calc menu. We're going to go down to linear regression, just like we did a few minutes ago. And you can either hit enter now, because your stuff is all in list 1 and list 2, but then you're going to have to type the equation into y1, or if you want, you can hit second 1, comma, second 2, comma, and then bars, y bars, function, y1. If you've got the 83, if you've got the 84, then you're going to go down a screen that says X list, and it's going to say L1, and Y list is going to say L2, and then it's going to have store regression equation, REGEQ. That's where you hit bars to get your Y in there. And actually, once you set that up, you don't ever have to change it again. You just take your arrows down that page to it says calculate, or on the TI-83, after you've got the information in, you hit enter. Okay? And the actual slope of that line is right at 427. Now when they use those 2 points, they got 414.2. That's because they only used 2 points. The calculator used them all.
If we have the TI-84, what do we put for the store reg?
Out there after RegEQ, hit bars, over to Y bars, choose function, choose Y1, and then it should copy it onto that screen. And then go down to calculate. You should be good to go. Okay? So what should...
I'm supposed to have.
Not quite. Let me see if I can figure out what's going on. Now you did a good job of keeping up, though. 0, 2, 4, 6, 8, 10, 12.
It might be my numbers.
I was going to say, you probably, my favorite trick is to transpose digits on this, so let me check your
My
numbers.
L1, L2 with us.
3508,
Yeah.
4098, 5126, 58. Okay, you left out one. No, you didn't, wait. 6599, 76, 29, 86. Let me look at my calculator because it actually could be me. So, did anybody else get what I got, or are you getting something different?
I got what you got.
Okay. 4508, 4198, 5126, 5804, 599, 7629. Oh, you left off 13. I just realized that. That's what you've done here on your calculator.
2013.
Yeah, you left off the 13 for 2013 and the 8893.
So it's one light short.
Yeah, it was 1 point short. So now,
I thought that would be enough to get it. Is this,
yeah, there you go. It was just because that 1 point.
okay.
You have to have them all. Okay? So if you press your Y equals key, there's your equation. They already loaded it in there for you with all the decimals. You didn't have to write it down and type it in. And if you want to see that that line fits, all you have to do now is just hit graph. And there goes that line. So, yeah, that line fit through those data points really well, didn't it? It's really close. Now, if you want to round that off, and that's fine if you want to round it off, since actually these are whole years and these are whole dollars, it would be perfectly fine to round that equation off to the slope being 427. And since that's plus or minus, then that's subtract. And just round this off properly to the, actually since this is a 9, I probably should have rounded that off to 850,677. But on that graph, you're not going to see that much difference anyway. Okay? So you can round it off to whole numbers. So basically, that's everything that we need to know for section 1.1. Okay? That's it. Now we've got about 10 minutes, so I want to show you, I want to give you a brief introduction to 1.2, and then I want you to watch the video that I've got up there. And I think the video that I've got up there is actually one from a classroom lecture, but the sound is better. So it should be all right. But I want to show you a couple things that will help you with as far as the arithmetic goes. So looking at example 1 in section 1.2, one of the things that we're going to have to do is we're going to have to find g of, a function of. Now that one through all the terminology, that's in the first couple of slides because that's going to be in the recording. What this says is this is a linear equation. It doesn't have to be a linear equation. It can be a different kind of equation. But this is a linear equation. When you see this equation and it says find g parentheses 3, the way you read that is g of 3, not g times 3. That's g of 3. And what that means in ordinary English instead of math language is it take g of x equation and plug in 3. Plug in 3 for x. That's all it's telling you to do. That's just a really short way to say do this. Okay? So in order to find g of 3 is -4 times 3 plus 5. And -4 times 3 is -12 plus 5. And -12 plus 5 is -7. So g of 3 is equal to -7. Okay? G of 0 is the same thing. G of 0 equals 5. And I would do the same thing with -2. You plug in -2 and you get a number that says G of -2 is whatever that number is. G of B is absolutely no different from what we just did. That says take G of X and instead of X, plug in B. Okay? All there is to it. So it's just a matter of terminology. You can do the arithmetic on your calculator, although this arithmetic was kind of easy, so it wasn't all that hard to do. I will show you next class period how you can use your calculator the way we were using it a minute ago, where you type your equation in Y1 and then just go over to your home screen and get Y1 and put parentheses after it with the number that you want it to plug in. The hitch is it won't do B. It only works numbers. Your calculator does arithmetic, it does not do algebra. So you need to know how to do this by hand, but your calculator can help you with the arithmetic. Okay? We're going to talk a whole lot about functions, and you're going to get a lot of practice with functions. And then we're going to talk about supply and demand. We're going to do some graphing. So there is already a recording up there. You can go ahead and watch that one. And then I'll show you the technology for 1, 2.
So we have to turn the homework before we go over in class tomorrow?
No, I'm going to change it. Even though that due date's there, I don't count off that if you put it in late.
So what's the video online? So what's the video online for?
That's your lecture, so you need to go ahead and have your notes done, watch that video, and do your notes for section 1, 2 before you come to class.
So when's the homework due? It won't be, our homework won't be
Your homework won't be actually due until
next week.
next week when your class actually is.
So Toby won't be doing it either?
That's what I'm saying.
Okay, so
Oh,
I
yeah.
thought you had to do tomorrow.
Yeah, I've got it due tomorrow because that was originally how I set the calendar up, but it got kind of off track in the beginning.
So that's why it works, is you watch the lecture video, take the notes at home, and then you come in and go over the problems.
Right.
Okay, I didn't know how it worked.
Yeah, that's how it works.
You just want us to turn in the homework class notes on the show.
Yeah, but you don't even have to turn in your class notes.
I know, just the homework.
Yeah, just the homework, just the show me homework.
Okay, and the homework will never be due until after we go over that chapter. Class, right?
Actually, once you do those notes, I think you ought to try the show me homework, because if you've just done those examples, every one of those problems is just another example of the same one that I just did.
Yeah, but it'll never be due after, I mean, it can never be due before we go over it. class correct?
I won't be graded before we go over the class.
So that means it won't be due, right?
Well, no, it's due, but I don't count off for it being late, let's put it that way. You really should get it done, maybe not tonight, maybe by Monday, because that gives you 3 days to get it done.
I came up here to your office again. You weren't there. I'm gonna have to do something. That's okay. I'll call you tonight, or I know you got time right now, but I got class.
I know you do. What time, you said you get out at,
Are we still meeting today?
what time? Yes,
Or-
yes, right after my other class.
Which I have you in.
Yes.
Is the 1.1 in my math lab due tonight?
I think it is, yes.
Okay.
Because you should be able to do 1.1 now with no problem.
So everything from 1.1 should be done today.
Yeah,
So I'm going to show me everything then.
yeah.
We do this, right?
Mm-hmm.
I already,
Good job.
I got up in the middle of the night and solved that one. It's number 17, but I got it done.
Okay.
So now, we're doing 1, 2.
Right.
So you want us to open this, watch this,
Right.
the documents, the notes is in the folder, I already got the notes.
You already have the notes.
So go over the notes where we haven't done and homework. When can I come in and meet with you? I've got to practice the calculator unless I take that sucker and write them down. I know you got the things on the lab and that will help some, but probably like doing all this different graphing, zooming, all that, I need to probably get with you.
If you
and-
can't get with me, go over to the Learning Center. If our times don't collide like I wish they would, go over to the Learning Center, and Miss Perry should have somebody over there that can help you by now. Or she can help you,
They're having problems at the Learning Center and Trio because something about funding.
Yeah.
The semester's starting and we gotta get going and they've got nobody over there because they're all fussing over money or whatever they're doing.
I know. But
So
Miss
do
Miss
the-
Perry did say she would have tutors starting Monday.
Okay, what is her hours over there?
They used to be 8 to 4. I think now they're like 8 to 6.
How about Friday? Could you meet with me on the Friday? 'Cause that's
Yeah.
what I like to do because that's the
Yeah.
off day.
Yeah.
I will drive out here and meet with you.
Okay, just
Are
send
you in
me.
your office Friday?
I am, but it's not till late in the afternoon unless I know you want to come earlier than that.
When can you meet?
Well,
I'll come
normally,
in whenever you want.
let's say about 10:30,
Okay.
okay? And I'll make a note that I'll come in at 10:30 on
10:30
Friday
Friday.
instead of coming in late.
I submitted this homework on Tuesday. I was wondering if this was acceptable or.
Siri, set a reminder for 9 o'clock on Friday
Okay.
morning.
This is fine.
Okay, and also there was a question on there. I don't know if I put it in the question form for you to see, but I didn't complete
Meet
it.
Miss Fleur.
No, I just don't know where.
Okay, I'll remind you.
Okay, I'll see you Friday.
Okay. Have you went ahead and worked ahead on any others maybe?
No,
Because there's no word problem on 1.1.
maybe it was 1.2. Maybe it was in the notes and we didn't cover it.
Pull up your chapter 1 notes. Yeah, see, that was that's the next lesson. Let me look at your notes though, because it may be word problem.
Well, I think I might have printed it out, but I couldn't find it. It's so confusing. But I couldn't like find a similar one to work off of.
Yeah, because you've got the word problem we did in class today done correctly.
Yeah, I don't
And you
know.
don't have 13 because I forgot to put it in your notes, but
Oh, maybe, gosh, I don't know. I think it was, I guess if I find it, I'll email you.
that or just put me a note in Shelby without, you don't have to email it.
Oh,
Just
okay.
put me a note in Shelby and say, I found the problem that I'm stuck on. This is it.
Okay, all right.
The only thing is, what you want to do, if you want a message just to me in Shelby, put it in one of your folders.
Okay,
If you put it on the class discussion, then that's everybody in class,
okay,
okay?
okay.
All right, thank you. You're welcome. And if you need me later on today, just drop by.
Okay, all right, thanks.